And okay, all right, if I need to find an angle, a theta, and I know the sine of that is 0.8, what do I use to find that angle? My inverse function, okay? So what we're going to put into our calculator is inverse sine of 0.8. Okay, when we put that in our calculator, what do we get out? 53? We're going to round to the nearest degree, okay? Okay, did everybody get 53 degrees? Okay, what your calculator spews out, we're going to call a reference angle, okay? So we're going to call it a ref angle. Reference angle. Okay. Today, we have some constraints, okay? And it's going to tell us for each problem. Our constraint in this problem is that our angle is between 270 and 360. Well, if I draw my coordinates, what coordinate is it in? Or not coordinate, sorry, quadrant. What quadrant is it in? Quadrant 4, yeah. This is our 270 to 360. Does everybody agree with that?
Yep.
Okay. Well, so I want an angle that's 53 degrees, but is down in that quadrant. Okay? Well, remember, when we draw our angles, it's always the angle that it makes with the origin and the x-axis, okay? So, do you think, or you tell me, is it true that this angle is also 53 degrees? I can make an angle down there, right? No? Maybe?
I don't know what's going on here.
Isn't that angle 53 degrees?
Sure. People that work 53 degrees.
I label it 53 degrees. Okay. It's the same as this angle up top being 53 degrees, right? It's just an angle at 53 degrees. Okay. But when it's down here, we used to call this negative 53, right? Well, I don't want to call it negative. I want to call it something between 270 and 360. So how can I figure out what to call this 53 degrees that's between 270 and 360? From 360, good. So we're going to take 360 minus our 53 degrees. And what angle does that give me? 307, good. Doesn't 307 have the same picture as this if I go all the way around? Yeah.
So then do you even have to like draw the triangle then?
No. I think it helps.
So you just minus the
Yeah, so like if we were close to 180, we'd use 180, but we were closest to 360. Yeah, John, what's up?
So yesterday in the homework, you wanted us to say like negative 53 degrees?
Yep, because we want to be between negative 90 and 90. Today, it's going to tell us for each one. So like yesterday we had our 3 rules, like sine and tangent were negative 90 to 90. Cosine was 0 to 180. Today, each problem is going to have its own constraints.
Because I did like this yesterday.
Okay. So there's stuff from yesterday.
I should have not told you that.
Probably not. Okay. I want us to draw something on our notes. It's our quadrants. Okay? What we're gonna write in it is A, S, T, C. Okay? What this means is that in each quadrant, that's the thing that's positive. The only thing that's positive. So in my top one, everything sine, cosine, tangent is positive. In quadrant 2, the only thing that's positive is sine. Quadrant 3, the only thing that's positive is tangent. Quadrant 4, the only thing that's positive is cosine. Okay? Some people call it like all students take calc. I think that's all I've heard. I don't know if you want to come up with a different acronym. It's appropriate. That's fine. That is going to help us determine what angle or where I want my angle to be. Okay? We know that no matter what, our angle always has to be at the origin or with our x-axis. But this is going to help us determine what quadrant we want to be in, based on if my value is positive or negative. Okay? Alright. B. I want the tangent of an angle to be -5. How can I figure out what my reference angle is? Use our inverse. Good. So I'm going to type in my calculator, inverse tangent of -5, and it's going to spit out something. -79 degrees. Okay. Yeah. Your calculator should be in degrees. We want our reference angles always to be where everything's positive. Okay? Well, right now, -79 degrees, that's down here, right? Everybody agree this is -79 if I labeled it? Okay, so if I want to put it up in my first quadrant, all I'm going to do is draw my angle and label it 79. It should be way closer than 90, but that's okay. Just pictures. Okay. That's my reference angle. My reference angle is positive 79 degrees. Okay, reference angles are always up in quadrant 1. Okay. I want our answer to be between 90 and 180. That's not here. Where is that? The second one. Okay, my quadrant 2. That's over here. Okay. So if I make my angle, what angle do I want to be down here? 79. Okay. The only problem is this whole angle is in 79 degrees, right? I gotta go from here over here. This is the angle I want. Because that's the one that's going to be between 90 and 180, right? So how can I figure out what this angle is, my whole angle? Or 180 minus 79, yeah. If I take 180 minus 79, what do I get? 101. Is that between 90 and 180? Yep. Okay, helpful hint. I don't know if you want to write this down, but we will never subtract from 90 or 270. It's always going to be 360 or 180. Okay? So whenever we subtract, it's always going to be from 360 or 180. We're not going to use 90 or 270. Okay. On C, I have the cosine of an angle is -2/3. How do I find my reference angle? Inverse cosine of -2/3. And what does my calculator spit out? 132? Okay. Is that between 180 and 270? Nope. That stinks. So I'm going to draw my axes. It's in the third quadrant. Where's 132? It's over here, yeah. Okay, before I can do anything, I need to find this angle. This angle isn't 132, is it? No. I need to find this little angle that makes my triangle. How can I find that?
48.
48, how'd you get it?
Subtract.
Subtract it from 180. Good. So if I take 180 minus 132, Kate says that I get 48. So my reference angle is 48 degrees. Okay, that's the angle that's going to go inside my triangle. Okay. Where do I want my angle to be? Do I want it to be 132 or 48? No, what do I want it between? Yeah, I want it between 180 and 270. What quadrant's that in? The third one. Okay. So, if I draw an angle here, what's going inside my triangle? My 48, my reference angle. Okay. Well, I need this whole angle. So how can I figure that out? Add it to 180. 180 plus 48 gives me how much? 228. Is that between 180 and 270? Mm-hmm. Okay. So if we were going to write down in steps, first thing we do, put this in your calculator, see what you get. Okay. Second thing, from that number, find your reference angle. Sometimes it will be a reference angle. So if it's between 0 and 90, you don't have to do anything. If it's more than 90, you got to put it, or less than 0, you got to put it into our positive quadrant 1. Okay. Then you just got to put your angle, your reference angle, where it's supposed to be in your constraint. And then use 180 or 360, add or subtract your reference angle to get the whole angle that you're looking for. Okay. Questions? None? Okay. Alright, this next stuff is a little bit different. The good news is it's kind of like Algebra 1. Okay. I need to solve each equation for my angle. Okay, the first equation I'm given is 4 cosine of theta minus 1 equals cosine of theta. Okay, I'm going to write this kind of like how you're used to seeing it. This is kind of the same thing as 4x minus 1 equals x, okay? Except instead of x, I have cosine of theta. Would you agree they look the same? Kind of? Okay. How would we solve this if I wanted to use the least amount of steps possible?
Plus 1.
Plus 1?
No.
What if I told you I want to do the other thing? Minus our x's. Okay. You can do it the other way, but this one has less steps. We're going to do it this way. So if I minus 4x, what do I get on each side? On my left side, what do I get?
-1.
Negative 1. What do I get on my right side?
-3x.
Negative 3x. Does everybody agree on that? Okay. Well, now we're just going to translate it over to our cosine. Okay. Same thing, except instead of subtracting 4x, I'm going to subtract 4 cosine. Okay. Still get the same thing on my left, -1. On my right, I just get -3 cosine theta instead of x. Okay. Let's go back to our red algebra. What's the next thing you would do?
X equals 1/3.
Yeah. divide by -3. And Kate says my negatives cancel and I get 1/3. Well, same thing over here. Except for instead of x, I have cosine theta. Okay, so I have 1/3 equals our cosine theta. Okay. Well, I want to know, I'm finding an angle, right? My theta is what I don't know. I want to know what angle has a cosine of 1/3. How do I find angles? Use our inverse, very good. So I take my inverse cosine of 1/3 into my calculator. And what do we get?
71.
Can you give me 2 decimal places? Good, awesome. Okay. Everybody good through there? Okay. I'm gonna draw that all students take calc thing again. Where is 70.53? What quadrant? Quadrant 1. Okay. Is my cosine positive in quadrant 1? Yeah, everything's positive in quadrant 1. Okay. So I have my angle that's positive in quadrant 1. Well, what other quadrant is cosine positive in? In 4. Okay, now I know I wanted positive because this is positive. Okay, it's also positive in quadrant 4. Okay, so I need to figure out with my angle of 70.53, that's my reference angle. I need to figure out what degree that is all the way around. I don't want to use negatives, okay? Excuse me. So how do I figure out what that whole angle is in quadrant 4? Minus a 360. So I'm going to take my 360 minus 70.53, and what do we get? Good. Okay. So both of these angles have a positive cosine of 1/3. Okay, these are in degrees. If you look at the top, it asks for them in radians. How do I convert degrees to radians? Pi over 180. So if I multiply by pi, divide by 180 for both of these, I can tell you that the first one becomes 1.23 radians and the bottom one is 5.05 radians. When you don't have nice angles, like our 30s, 60s, 45s, 90s, just times it by pi over 180. Some of them you'll see we get those 30s, 60s, which are nice, and we can just leave them in pi. Okay. Questions? Okay, let's do another one. Okay, I have -3 sine of theta plus 1 equals negative sine of theta. Let's get our signs together. What am I going to do for algebra? Yep, add our 3 sign. Good. On my left, I'm just left with 1. On my right, I have what? 2 sine theta. divide by 2, good. So I have half is my sine theta. Ooh. Does that half look familiar? Maybe. I need an angle where the sine is a half. 30, very good. So our theta is 30 degrees. If you didn't know that, all you do is take your inverse sine of a half in your calculator. Okay, good through there? So 30 degrees is my reference angle. I have my all students take calc. We are looking at sine. I have 30 degrees, which is in my quadrant 1. Is that okay? Yep, so we got our angle there. Where else is sine positive? A second quadrant, so over here. So I need to make an angle where with the x-axis makes 30 degrees. What angle is that going to be? 150, how'd you get it?
Minus
180 minus 30 gives me 150 degrees. So these are my two angles. I want them in radians. Good news, easier. 30 in radians is pi over 6. And 150 is 1/6 short of being a complete one. 5 pi over 6, good. Would I mark it wrong if you put in your calculator into the pi over 180? No. If that answers any question. Okay. Getting better here. Okay. Moving on to the next one. Okay. Last two. Oh boy. 2 tangent of theta plus 5 equals 0. What do you guys want to do? Subtract tangent. We can do that. Either way isn't going to matter, right? What's next? Divide by -2. So I have a -5/2 is my tangent of theta. I don't know that one. Put it in our calculators as the inverse tangent of -5/2, and what do we get?
-68.1.
2? 2, does that work? Yeah, okay. Okay. I want my tangent to be negative, right? Do you agree with me on that? That I want my tangent to be negative? So, all students take calc. Where is it negative? 4. Where else is it negative? 2. Yeah. It's positive in here and here. So I want the ones where it's obviously not positive, aka negative. Okay. Like I told you before, we don't want negatives. So this is in quadrant 4, right? The -68. But I want to make it a positive number. So what do I have to do to this -68? That's like -68.2, right? But I don't want this angle, I want this angle. So how do I figure out what that is? Minus it from 360. So I have 360 minus 68.2. Or if you had your negative, you could add it. either way looking at it. $291.8. Yeah. Okay, while we're working on this one, let's put it into our radians. How do I get to radians again? Pi over 180. And I get 5.09. Okay, that's just my quadrant 4-1. Okay. Find my quadrant 2. I just gotta put my reference angle in here. What's this angle supposed to be? 68.2. I need this angle. How can I find it? Minus 180. 180 minus 68.2 gives me 111.8. Yeah? Yeah. And if I put that into radians, it is 1.95. So for these, you'll always have two answers because it's either positive twice or negative twice. Okay, so always have two angles. Questions here? One more, I think we can do it. Okay. How am I going to solve 2 cosine theta plus square root of 2 is 0? Any way you pick. Minus square root of 2, okay. Now how do I solve? Divide by 2. So I have the cosine of my angle is negative square root of 2 over 2. Oh my goodness. Does that look familiar? What angle has a leg of square root of 2 over 2? 45. So my angle that I'm looking at is 45 degrees. However, all students take calc. Do I want that 45 triangle, or my cosine, to be positive or negative?
Positive.
Say what?
Early.
I want my cosine to be negative, yeah? Where's cosine negative? 3? Where else? Oh. Okay. So then we go on to draw our little pictures. And if I'm in quadrant 2, let's do 2 first. And this angle is 45. What's the other angle? The whole angle. 135. If I put that into radians, I get 3 pi over 4. Guess not maybe so. And then in quadrant 3, I got 45 here. I want this whole angle. Or I can just take my 1 pi and add a fourth to it and get 5 pi over 4. How do we feel?
Figure the degrees out on that then?
Since we want it in radians, and we know our pi's over 4s, I just left it with pi over 4. If you took the degrees and then manipulated it, we multiplied by pi, divided by 180, that's fine with me. I know my pi's over 4, so I just left it here. Okay. So solve algebraically, find our reference angle, find where your function is positive or negative depending on what you're looking for. Add or subtract from 180 or 360. Questions? You guys are just a lively crowd.